Yonatan, at Deci, you're applying AI to build better AI systems. So let's begin with the problems you saw with the way we build AI systems today that led you to start Deci.
We started this 3 years ago, around 2019, October 2019, and it was quite the early days of deep learning. I believe that we're still in the early days of deep learning and we learn new stuff every day. But at that point in time, it was very challenging to build deep learning models, not talking even about deploying them into production. And the process was super manual, like doing trial and error iterations, changing the model, changing the hyperparameters, and iterating in order to get model to reach the maximum potential in terms of accuracy. And we started to see companies starting to shift those models to production. And then they are facing new challenges about deployment and how to take those models to production and what hardware, how to utilize the hardware well, how to run efficiently in production. Those was the early adopters of the deep learning technology. And then we connected two dots about how manual is the process of building the models and how complex is to take them to production with high performance. And we understand that we can do a major change here on how people build model in order to get them better to production. And that was the whole idea. We saw, like I said during my PhD, how corrupted is the process of building a model. Millions of, not millions, but dozens of training processes that most of them doesn't reach the accuracy metrics that you're looking for. And then when you reach that point, the model is not yet good enough. And we can kind of catch two problems here. One of them is how people build models and automate that process, but not only for automating the process, but also for gaining a huge gain in performance in the production environment. And that's kind of what we saw. It was the early adopters trying to push deep learning models into production those days, but we kind of extrapolated how big the problem will be when the model will get larger and expand, and the market will have more practitioners trying to build models and take them to production. So this is what we've seen at that point in time, both from large companies and startups using deep learning.
And it's still early days for sure, and it's still challenging to deploy models. But let's talk about the Deci's platform capabilities. You help organizations deploy models in cloud, edge, mobile, and data centers. What was and what is the main insight behind Deci? What is that thing that helps you improve the way we deploy the models?
So in a high level, what we saw that people are walking step by step in the sense that they're first trying to get to the accuracy that they're looking for, and then they understand, oh, we've got to the accuracy, but the model is too big. We can't deploy it into production. We can't run in run it in the scale that we are looking for. And then they try to iterate on optimizing the model with several techniques. And what we try to do is to kind of change how people build models by automating the process of the model design, of model selection, using neural architecture search, which is the core technology of Deci, in order to design models that are more accurate, faster, and exploit better the trade-off between accuracy and inference performance on any given hardware. And the idea is to help data scientists to build better models so it would be easier to take them to production. But it's not limited in that, because the tools and the infrastructure that is needed today in order to take models to production is insufficient. So our platform is kind of an end-to-end, a place to build a model, train it, select the model based on models generated from the neural architecture search engine, and then deploy based on our tools into production.
For those who are less familiar with the neural architecture search, can you give a brief overview of what it is, how it evolved over time, and how it is applied currently at Deci?
Yeah, so neural architecture search is a family of algorithms that automating the design of the neural network structure, which called architectures. The idea is part of the job of the data scientist or the deep learning developers is something that is called model selection or model design. And that's an iterative process that is a lot of trial and error iteration until you get to the final structure of the model, the size of the model, the number of layers, the size of the layers, and there's a lot of many decisions that need to be taken in order to design a neural architecture structure. And the idea is that we can automate it, kind of an algorithm from the family of AutoML that automate the process of selecting the model, selecting the right model, or even designing the right model for the problem. So neural architecture search started around 2018 at Google. Probably there's some evidence for those algorithms before that. But at the beginning, neural architecture search has been, which called also NAS, has been used to reach the state of the art, like build models that are more accurate. And what and it's broke some records on ImageNet, for example, which is a very famous data set in 2018. But after that, we twisted the idea of neural architecture search to take this technology in order to exploit the trade-off between accuracy and latency. So we designed a neural architecture in an NAS algorithm that is called AutoNAC, which is not only aiming to get the best accuracy, but also looking on how the architecture, how the model is performing on the target hardware at inference time, and helping the data scientists to take decisions that are production aware in the sense that the trade-off of the accuracy and the latency of the model that is running in production. So it's a different flavor of neural architecture search that help design models that are production ready in the sense of the performance. And how it works is it's the basic, like the first generation of neural architecture search was quite simple. You design something that is called a search space, which is hundreds, thousands, millions of candidate neural architectures, and you just need a smart way to check, to validate, or to scan those this large set of candidates for the model. So that was kind of the old approach of model selection, and we had cross validation and other techniques in order to avoid overfitting. But in deep learning, it's a little bit more complicated because training a model is taking a lot of time. So we can't evaluate million of models, candidate models on our data set and train them and see which one is the best. So we need more clever techniques to do that search. And one of them, at the early days, it was reinforcement learning to drive that search. But today, this is technology is relied basically on AI and something that is similar to generative AI that can get an objective and generate a structure of a neural network. So we can think about it that AI taking the decisions of how the model will look like. So basically, it's AI that builds AI.
And how do you then validate the prototypes that AI built for you based on your requirements?
So that's a good question because two assumptions that we took that we can't run with a lot of compute in order to test those models because we try to build a product, not a research paper. Most of the neural architecture search algorithms that founded at the large companies like Facebook, Google, and others uses massive amount of compute in order to converge to a valid solution. And our approach was kind of we need something that will run faster. So um, we asked we designed that AI system to not only find the model, but also to tell us how it will perform. And the idea is that we get a metric out of the AI. It says that is a model, and that is its quality based on some internal metric that we develop. And then we can compare internally AI models and understand, okay, this is more powerful, this is less powerful, and ship those models to the customers that use the SaaS platform to request that generation of the NAS. So the idea is to shift that problem to be solved by AI in order to reduce the amount of computational resources that we need in order to um, actually verify each and every model that our platform generates. And obviously, as any AI system, it's not 100% bulletproof, but we're around 95% accuracy in the predictive capabilities of that model, which basically says that we hit the targets in the vast majority of the cases, that the platform generate a model that suits the customer's needs.
I see. This is interesting and novel. I think, did you develop that derivative metric that you now use as a proxy instead of testing the full scale test of the models? Did you develop it in house or you use some academia developed metrics for that?
The idea on how we developed that metric was a nice story about something that is also related to the company culture. We simply said, okay, we have 1 week to solve that problem, and we did a competition among all the deep learning researchers who find, and we had like kind of a data set with a ground truth, like I don't know, 100 of models that we trained and sorted based on their quality, and we said, okay, we need to find to train that AI model to give that quality metric that has the highest correlation with the ground truth. And it was a competition, and it was a very nice atmosphere along that week. That it was competitive, but in the good way. That everyone shared like kind of a Kaggle scorecard, a leaderboard with all the results of all the individuals that are trying to solve that problem. And on the last day, someone did a change to his algorithm and took the leadership. And the nice thing when you do such thing that we got, I don't know, maybe 5 or 7 uncorrelated predictive metrics, and we just assembled all of them into one metric that then improved further the performance of that metric. So that was a nice approach of solving something in an early stage startup that maintained until this day, like it was 2 years ago or something like that.
Yeah, this is the ultimate hackathon experience gone right. And the ensembling is, of course, is a beautiful idea. Okay, but then you figured out that just NAS is not enough, and you need to build a bigger platform with more capabilities. So why did you decide to go that broader path?
That's a very good question. One of our first design partners, we collaborated on some image classification task, and we ran that NAS, and the NAS produced a model that is 2x faster than the baseline that they were using in production. And they took that model and deployed it in production, and they said something like, look, we understand that this model is supposed to be faster, but we don't see any improvement in any metric in our cluster. And then we started to make some logs around the workload, and then we understood that the production environment had only something like 40% of GPU utilization. So even if we improved because of some other processes in the inference pipeline, like pre-processing the data, running the uploading to the GPU, running the predictions, taking the predictions back to the CPU, post-processing the data, and we solved the problem of only 40% of the entire pipeline. And we understood that we need wider solution in order to help people not only to build better models but also to deploy them effectively, because the model could be much better but they won't see it in production. And then we expanded to the deployment phase, where we give tools to compile, quantize, and deploy, also control asynchronous inference pipeline, like in the example that I gave now. And it become a complete deep learning development platform that data scientists and machine learning engineers use when the point that they have a data and they want to build a model until the model gets to production. So that was kind of a natural expansion for us to overcome some gaps in available tools and best practices about how to take models to production, that we still see. Even if that story was something like 2.5 years ago, we still see those gaps in production even today. There is no playbook on how to deploy models in the cloud or in the edge, and there is a lot of attempts to do that in many ways. And if we can help with some tools and that streamline best practices, that's a natural expansion to our platform in my perspective.
And in terms of the customer persona, how do you think about what's the best customer persona for you guys, or what's Deci is the best fit for?
So the platform is very, very horizontal. We see companies that uses us on computer vision on mobile devices and generative AI for NLP in the cloud. So those are completely different personas in many, many characteristics. So there is no one persona that like we target that this is the sweet spot and all the other is irrelevant. But we see some areas that some components on the platform give more and more value. For example, the NAS algorithm really help for data scientists and machine learning engineers that are building models to be deployed at the edge. At the edge, you have constraints with the model size and with the computational resources that you have there, and you want to build models that are small and efficient. And doing it manually is it's also almost impossible. And we see those developers that using our NAS in order to build those models to perform better on the edge devices, especially edge devices that need to run on real time, like in the automotive industry or security industry or manufacturing use cases. So all of those use cases that use computer vision on the edge in high resolution, in high throughput workloads, need to optimize from the model level at the top to the runtime level, the infrastructure layer, etc. So this is one of the segments that we see the strongest fit to build models using the neural architecture search. Another area that we see now growing is the generative AI, where we see basically generative AI is any model that is generating media. It could be text, it could be images, and we see that those models are very complex and computational hungry. So optimizing the runtime of those models by using graph compilers, using quantization techniques, and also deploying them more efficiently is something that many companies that entered into that field of generative AI are looking for at the moment. And we see a lot of companies, either companies that are doing video generation or text generation and other stuff in that domain, um, looking for solutions on how to deploy those models more efficiently in the cloud, because those models are very heavy. They take the most expensive GPUs in the cloud, and those companies that get to some level of traction, they're starting to think, okay, how this will look when we'll do 3x next year or something like that. And then they start to think about how we deploy those models, how we optimize, how we reduce the cost, how we make their workload more responsive and reduce the latency of the predictions of the models, so the product will be better. And all of those things that the machine learning engineers that are taking those models to production are thinking, especially on those generative AI large models.
You're basically talking about taking stable diffusion open source model is not enough. You then try to apply it to your production use case and you discover that it consumes a lot of resources and you start optimizing it, correct?
You can take that stable diffusion and you can deploy it quite easily. You can build an inference server, or do it as a monolith. But then you'll hit a wall when you start to serve more than a few customers or more than a few users. You'll see that you need more efficient workload. And it also happens in generative text. So, for example, if you want to take that T5 model by Google, 3 billion parameters models, and do some generation task, and generation task in NLP model are autoregressive, like running the generating one token at a time, and you need to run through the model several times in order to generate a sentence, not talking about generating something that is longer than a sentence. So you understand that you need something different in order to run those demos that you can use in the that those demos that you can use when you simply deploy those models as is, and you start to think about optimization at that point in time. We see large companies that shifted towards relatively large startups, and other companies that shifted towards that field of generative AI because they found their solutions that are better than the things that they have done with the classical machine learning or with the standard deep learning for image enhancement, image editing, and other stuff. So we see companies, it's not only like new startups that took that technology and starting from zero, but we see companies with very large customers and user base trying to push those type of models into their workloads, and then they need to think from the first day on how they do it smart, how they do it efficient.
Did you have a chance already to optimize some of those generative models and can share any outcomes of that optimizations in terms of improvements you were able to achieve?
Yeah, so we have optimized an interesting video generation that is video generation model that is running in a company. Um, so what they had is PyTorch model that they deployed as is in PyTorch, and when they use the deployment the deployment component in our platform, what they've done, they optimized that model, they quantized that model, and deployed it with tools that better manage the inference pipeline, like the pre-process, the inference of the model, and also concatenation of several models one after the other, one generating the image, one generating the audio. And that company, they were able to reduce something that is 3.5x in terms of the demand of computing their workload specifically. So it immediately translates when the cluster in full capacity to something like is more than 66% in cloud cost. That's the idea, or the calculation. When you have workloads that in high capacity and you improve the whole pipeline of the processing of the models with the pre-process and the post-process. So something that took one second can take now 300 milliseconds. So you can do it more than three times at the same time, and you get more out of the compute that you are buying. So this is exactly how performance can translate to cloud cost. But that's not the only value that they have saw. Their platform is kind of a SaaS platform that helps creators to generate video content. And what they really started at the first day, they wanted to have it respond quickly. It generates video, so it generates frame after frame after frame, and that accumulates to long turnaround time of their workload. So what they had to do is to optimize and parallelize some of the frames generation in order to return the video faster to the user that requested that. So another benefit is simply better product by having better, faster response from the server. So it's always a mix of several components of value. One of them could be latency and improvement in product. So one of them could be quality. Another one could be cloud cost, and it all sums up that it tools that help you get better and faster on your deep learning journey.
This is impressive. 2/3 of cloud compute capacity or expenses shaved off is very meaningful for sure. Let's now look at the other extreme. So, generative models are very compute heavy, and the other extreme is deploying at the edge, where you have very limited compute, much smaller models, but even more limited compute. So, what kind of interesting examples or case studies from that world are your favorites?
Yeah, so first of all, those are not so the opposite, because we see companies that their solution of reducing the cloud cost or improving the latency and the product experience on their mobile app, for example, is pushing those models from the cloud to the edge and run into the application. So it's not like one type of company is having generative AI in the cloud and another different type of companies having something running on the edge. Sometimes there are, in most cases, we see companies that having some of the workloads working on the edge and some of the workload working on the cloud. And sometimes they try to shift computation from the cloud to the edge. And sometimes they have some hybrid approach that in some cases they process on the edge or in some cases they shift to the cloud. And I think that in the future we'll see it more hybrid in the terms that what happening in the edge and what happening in the cloud. But if I need to think about a use case of something that is deployed on the edge, um, we're working with a video conference company that having that virtual background feature that we all know. And one of the things that, when I started the company, I started to pitch to VCs, and it for me it was the beginning of using Zoom. And I had my old computer with i5 CPU, and then I tried to turn on that virtual background feature on Zoom like three and a half years ago, and it had a pop up that says you need an i7 CPU in order to run that feature. That point is the point, like preparing to pitching to VC and seeing that pop up, that I took that screenshot of that pop up and I said, okay, that's the problem that we're trying to solve. We want everyone to have the opportunity to run those product features that are relying on video conference applications. So we're not working with Zoom; it's a different company, but we're enabling them to run those video editing or virtual background features or other video features in real time on the edge compute, either in the browser or in the native app that is running on the laptop on wide variety of laptops without limitations. So that was kind of a closure for me after seeing that need, trying to run virtual background on Zoom and closing that customer with a very nice technological success story.
What kind of improvements in the edge deployments did you see so far with your customers?
Yeah, so basically, what we see usually is improvement from 3 to 10x in performance. But also here, it's not only a story about performance, because sometimes the memory is more important because companies are trying to deploy several models to work side by side on the same compute device, and then they need to split the resources, for example, the memory of the accelerator with other models. So sometimes companies are more focused on reducing the memory footprint of the model. In these cases, we have done something between 2 to 5x. And when companies are focused on reducing the latency, we're usually doing something that is between 3 to 10x. So those are all use cases that we see, we need to remember that the edge is mostly about computer vision, and the cloud is, we have some computer vision in the cloud, but it's mostly about NLP, and the platform supports both of those use cases. So most of the case studies around edge devices are optimizing computer vision models to be smaller, to run faster on the device, while preserving the accuracy. So that's the whole idea.
Why not say speech recognition? Why only computer vision?
When we started the company, we started in the area in areas that we were familiar with, which was computer vision and then NLP, but and also it's an analysis of the market size. So if we needed to see how many computer vision models deployed on the edge and how many speech recognition models deployed on the edge, I think that it's about 5x towards the computer vision in market size. So we started from the areas that the market is large enough. I believe that in the future we'll expand also to the audio domain. Like now we're doing computer vision and NLP, and in the future we'll definitely do audio and time series and other use cases that we don't cover now in our platform, but it's just a matter of focus and time.
And on your other note on pushing workloads from the cloud to the edge to save on the cloud costs, that's definitely a trend that we should see more and more in the future. I agree with you 100%. It's a clever way for the companies that can do it to reduce their costs and offload those to the consumer devices that get more and more powerful by day, especially if we're talking about mobile phones. So it may be even a reason for a company to succeed versus the other to fail, I think, over time, if depending on how successful they are at pushing their workloads to the customers' devices, because then they can charge less for their tool or even offer it for free in some reduced capacity because they don't leverage cloud at all. Now, let's talk about the biggest challenges your team had to overcome so far to build Deci to the current level of capabilities.
That's a good question. I saw a comparison or a question like, what do you prefer, that it will be 2021 when it was relatively easier to raise money but harder to recruit a team, or 2022 when it's almost impossible to raise money but easier, a little bit easier to hire great people? So that's a good question, and I think that is also like, it always like the balance between those two. Both of them are really hard, but I think that it will has to go like step by step. So I think that once we raise some money, it becomes super challenging. Like in the last 2 years, to hire to build a strong team, and we invested a lot of our time and resources in order to find the right people to build our team. So that's one of the things that was a huge challenge. We saw all the large companies. Our R&D is mainly in Israel, and we saw that large companies like Google, Facebook, Amazon coming to Israel, uh, paying a lot of money to the candidates, and we lost several candidates when competing against those tech giants. And since, I don't know, 5 6 months ago, we saw them in a hard freeze, and things become a little bit easier for now, because you don't have for each every good candidate that you find a counter offer from Google. So that was one of the challenges. I think that the second challenge is um, the fact that we are defining a new category in an early market. Um, that's something that requires a lot of intuition, let's call it. I think that today the market is more mature than what we had like when we started 2 3 3 years ago. And one of the things that was very challenging is to understand where the market is going and what you need to build in order to serve the majority of the market. And I think that we made good choices. I think that uh, we discontinued some projects, which is also good because you need sometimes to let go from projects that you invested a lot of effort in them. So it's kind of a balance. It's a combination of research, intuition, and some guess and luck, I guess. Trying to define a new category in an early market before the market stabilize. It's something that is really hard to do, and the thing that helped us sit in that thing is to find the use cases and the people and the design partners and early customers that kind of represents the market and represent where you think the market will be in 2 3 years, and build something that they will love, and then try to expand. And then we saw that it's like we have a very strong core of our platform that we can now scale. So that was kind of how we treated that missing data or uncertain market trend in order to overcome that point in the deep learning market.
How did you go about identifying that direction, the one that is right and that will be relevant for the next several years?
That's a good question. I think that it's 30% signals and 70% intuition. I think that it was quite clear that deep learning are getting models are getting larger and larger. It was quite clear that it takes a lot of time and iterations to build those models, and connecting those two dots of information together was quite straightforward at the beginning. But then um, continuing seeing those evidence that those two dots really connect was not easy in the early stage of the product, because you don't really at the point where you build everything that you want and you're working based on some intuition that if you'll connect these two problems together and you'll solve them, and the market will go, and people will go more to production, you'll have something people like, and I think that it was 60 to 70% intuition. Today, we're making something like, I don't know, dozens of sales calls a month. So we get a lot of feedback and a lot of iterations with the market. But in the early days, it was much harder to get those signals from the market.
Because market themselves, the organizations themselves, not necessarily yet known what kind of challenges they will face, and had no clue about how they will be, what kind of products they will need to overcome those challenges.
Exactly, and even when you ask them, you have so many, like you overwhelmed. You heard so many problems, and it was really hard to identify what are the real problems and what are something that they're struggling with last week and they will solve next week. So I think that that's the second part of like getting signal from a very noisy market that everyone have different problems and struggling with different stuff to understand what will be the major problems of that market 2 3 years after.
How did you go about finding your first design customers and convincing them to work with an unproven team, unproven startup?
I think that we just reached out very aggressively to everyone we thought will be a fit. Um, and we found a couple of them, and we I don't know why they they agreed to work with us. I think that when you have a problem and someone tell you that he can solve that problem, I think that your first idea is to try it out. So I think that that was the case at that point in time.
Yeah, that was I was going to ask about. What was it that they felt the problem most acutely out of all the organizations you reached out to? That those few felt it so strongly that they were ready to work with anyone who can help them solve it.
I think that like any something in the early days, you hear a lot of no's. So we heard like no several times for people that it wasn't their priority. They're not at the stage in the development process that they were focused on performance or other reasons why it's not the right time or it's not the right solution for them. But as I mentioned, we reached out to as much as we could in order to find those early customers and design partners to build our technology and product based on their feedback.
When you look back at that process of securing your first customers, what are some of the things you think you did right? I think reaching out to aggressively to as many as possible will be the one of the things you've done right. And what are the things that you have done differently if had to do it again?
In most of the time, we had like business orientation. So we were selling from the first day. And I think that we might be able to shorten that process if putting business aside for the very beginning and trying to get those real design partners without putting business constraints on the engagement. So I think that that was something that I think we could do better on the 3 to 5 first customers, design partners. And on the other side, the fact that we reached out or we find our way to talk with many of them, we had a good sampling of the market to understand the problems, and we were able to work with several design partners in the early days. So it was good. We didn't do like overfitting for one problem of one customer or something like that.
Okay, let's turn to you personally. You had a PhD on uncertainty of deep learning models. I'm curious about your thoughts on that subject overall, the state of the art with dealing with uncertainty of the deep learning models, and what's your ideas overall and the thoughts overall on how this will evolve over time.
So let's first talk about what is uncertainty estimation in deep learning models. The idea is simple. We want a model not only to give us prediction, but also to give us kind of a confidence or to be self-aware of the confidence of its predictions. And the idea is how can we build models that are both accurate but also can rate their own predictions. If you think about people, and there is will someone that is correct in 80% of the time, but he can't say when he's not sure, and you'll see another person that is correct in 75% of the time, but on the other 25% he can say that he's not sure about his answer. You'll prefer to work with the one that can tell when he's confident and when not. So that's the same idea on deep learning. We can think about a medical application where you want to triage patients, but you need to you need to use that model that doing that process, but the model can say also, "I don't know," and please send it to a and the system send it to a human doctor. And with that capability, the models can be embedded into real life mission critical applications earlier because we have safety mechanisms to and railguards to understand when those models are false. So that was the topic of my PhD and several works around this area. I think that in terms of taking that to industry and real life applications of deep learning in production, we're still in the early days. We see that area of model monitoring and model explainability that is in some sense related, but it will take some time until we'll really understand how to treat model confidence in real life applications. And that's something that's still not happening in industry. We have some companies focused about the model monitoring problem, and one of the main properties of that model monitoring thing is to raise those flags when something is different than expected. But it's still the early days. I think that in the future, in order to rely on those models and be self-assured that those models are working well, we need them also to give us feedback about how much they are confident with their prediction, and this will help us kind of um, rest assured that the models are making their job well. And I'm talking especially about areas where the models are doing mission critical tasks, um, autonomous driving, robotics, and healthcare use cases and others. Those are the main verticals, in my perspective, to employ uncertainty estimation mechanisms in order to monitor the models.
Right now, it seems we rely on humans to monitor and control the model's outputs. So a human being serves as that uncertainty estimator, or at least maybe not an uncertainty estimator in a proper sense, but more of a validator and a safeguarding mechanism for those models. And the generative AI is kind of well published how much of an issue it has with the reliability. So, do you think it's also an architecture problem and we'll have to develop new architectures, maybe beyond transformers, to get to the to be able to actually enable this monitoring or this estimation of the uncertainty?
Yeah, we see that problem also in generative AI, and in some applications, like when we want DALI to produce an image, if the image is not exactly what we prompted, it's one thing. But we had that case with Galactica, uh, generative model by Facebook that took down because it kind of generated fake research results. And also, when you ask ChatGPT some stuff, it will answer with a lot of confidence, but sometimes it's just not correct. So I think that also in generative AI, in some of the application, we have that reliability problem. And I think that if ChatGPT, for example, could say, what is the confidence that the answer is correct, or even kind of highlight areas in green or in red, whether the model has high or low confidence in its prediction, it could be something that is very valuable for the user in order to understand how to use those predictions. I think that in general, all the generative area is less, let's call it mission critical tasks, where a mistake can be a mistake has a lot of impact. Um, but it will require also those types of safety mechanisms in order to keep the predictions something we can work with. As for people being kind of the uncertain estimation of those models, I think that people are good on doing some job, but they're not so good on checking some other's job by our nature. So um, if you think about that you need to drive or to be a safety driver, I believe that for most of us it will be easier to drive than be the safety driver. And this is why I think that giving people to do that AI safety work is quite dangerous at the moment. Also, if you give someone to check facts that ChatGPT produces, it will be hard to say which of them correct and which are not. So I think that that has a kind of inherent problem that the only way to solve it is in the approach. It's not exactly in the architecture, although one of my papers propose a new architecture that also can produce the uncertainty score and the confidence score. But I think that the solution for that is a different approach on how we use those models. If we use those models with their confidence, and the model will be transparent about where they how they got to that result and how confident they are in the result, it will be much easier to decide whether to rely on those predictions.
But do you think we haven't built that uh, confidence score into the output yet, just because we never got around to do that? Or there are more deeper reasons why it's technically challenging to build it?
I think that in the discriminative task we have quite well confidence scores. And the generative area is quite new, so we need some more time in order to get to the right metrics and also how to embed them in the human computer interaction in a way that the human will be able to understand where are the limitations of that nice AI paragraph, that AI generated paragraph that we read. So I think that it's a matter of time.
Let's talk about the future a little bit. And how do you see the way we develop AI systems will change in the future? One way we talked about is having the confidence built or engineered into the systems. What are some other ways that the way we build AI systems will change?
That's a good question. I think that we'll see more types of personas that are entering into the field. So today we see the early adopters, which got high proficiency in building AI systems, but we need to bring that bar lower in order to more people to enter into that field. And this is something that will happen naturally over the next few years. And I think that also Deci with our open source that is called SuperGradients kind of lowering the bar to enter into the deep learning field and train some models, use some pre-trained models. And I think that what happening in open source is in general is very important to making AI more accessible, affordable for everyone. So this is one trend. I think that we need more people that are building AI, more practitioners in the field that can take that the AI forward to more and more verticals and applications. And we need to supply them with the right uh, tools and best practices, pre-trained models, and whatever we can do in order to make that impact on the world with AI. So that's one thing. The second thing is how those models that we know today will penetrate into more vertical applications in industries that haven't been used AI in the past. And I think that that's something that we'll see more and more AI doing stuff and helping people in tasks that didn't use AI before, and automate, streamline processes, either if it's business processes, personal processes, or other stuff, in order to help people do their job better and faster. So that's another trend. We see what happening now with the generative AI for in the computer vision for designers, and what happened in text for authors. And I think that it will really help people to be more productive. And that's the next second trend, I think, in AI. I think that AI will continue to go to larger and larger models and more complex. It makes two challenges. One of them is the training of those models that require a lot of compute, and the second one is the inference of those models. And this is exactly where Deci fits in to help companies deploy those large models and run those inference workloads very efficiently. And this is something that will gain a lot of traction, in the sense that many companies will start to rethink how they can deploy those models more efficiently, how they can optimize their workloads. And this is something that we'll see starting to happen, especially when we're connecting it to the economic downturn that we're experiencing at the moment. So those two dots together will bring many companies rethink how they deploy deep learning.
The bigger the deployment becomes, the more important it becomes to make it efficient, because every percentage point of additional efficiency gains or additional cost reduction, now when the model is deployed at scale, becomes more and more meaningful and justifies bigger and bigger investments at the stage of the model optimization. So that's definitely a tailwind for Deci. What are your long-term goals for the company? What do you want Deci to become?
I see Deci becoming as the go-to development platform for deep learning. So basically, all the models, all the best practices, all the tools are there to do the end-to-end development from the day you have the data and you want to build a model until the day you deploy it either in the cloud or in the edge. So kind of closing that loop, doing being the end-to-end platform and being the go-to for practitioners to build on top, either if it's on the open source layer that we have out there that is called SuperGradients, or on the commercial tiers. But we see it as a go-to for people to simply start their AI journey or deep learning journey on the Deci platform.
A universal platform for developing deep learning systems. Now, when you talk to, say, entrepreneurs who just starting their journey building an AI powered company, what kind of advice do you give them?
First of all, buy GPUs for a data center. I'm I'm kidding, but they need a lot of GPUs, so they need to start with something. But on one hand, you need to think big, because AI is really something that is going in a 10 years, 20 years perspective change the world. On the other hand, you need to find a problem, a small problem that you can solve well now. And that trade off between your end game or your end goal and what you need to do in order to raise your next round is very challenging. And I think that you need to balance between your ambitious dreams and goals and the milestones that you need to cross for the next stage of your company, and balancing between them, between the short term and the long term, is very complex.
It is. And it becomes even more critical these days. You may have more leeway when the markets are excited about new things and money are flowing freely, you can have more month or more time to experiment with your ideas, and investors are more patient. And at this point of time, we're getting those investors less patient. They want to see the results faster. So you should be able to focus on the areas where those results can be achieved faster. On the flip side, as you said, I think if you manage to secure capital and find the product market fit, the access to resources like great people gets a little bit easier during the downturns. So it's a good thing for those companies that have resources to bring those people in.
Absolutely.
Okay, Jonathan. This is the last question we had. Where can listeners learn more about the company? Where they can follow you on social media, and also talk about SuperGradients, the open source training library.
Yeah, so a few months ago, we open sourced SuperGradient. SuperGradient started as an internal tool for us to train deep learning models, and then it started to evolve and have more and more models and more kind of best practices, from data augmentation to training tricks. And we decided to open source it and collaborate with the community on building that tool, and bringing it to make it public to people to use that tool. So you can just Google super gradients and find the repo on GitHub and use it. Contribute some code if you'd like. Open some issues if you'd like. And this is one way to experience a little bit about what this is building. But other than that, we have our deep learning daily community on Discord that you can join. You can follow us on social media, either Twitter or LinkedIn. And just visit our website to read some materials, or contact us through the website.
We will add all those links to the show notes. Jonathan, thanks a lot for joining me today. It was great talking to you.
Thank you very much. It was a pleasure.